H2S Basic Safety Tutorial. Some places where H2S is found: gas plants, refineries, petrochemical plants, sulfur recovery plants, underground mines, tank cars, tank trucks, oil and gas wells, battery stations, commercial laboratories, septic tanks, sewers, manure handling areas, pulp and paper mills, pipelines. H2S is hazardous and toxic compound. Present, in the form of a gas, it's colorless and odorless. Flammable, at 260 degrees centigrade, it's get easily ignited, occurs naturally, decaying organic matter. In low oxygen environment, sewer mines, hot springs. H2S entry, in general formation, during oil and gas extraction, on and offshore. Having vapor density, of 1.19 and 20% heavier than air, gravitate and pool in, lowest point. Pits holds tanks depressions. It is soluble, and remain in contained, within water, oil, sludge or mud until agitated, depressurized or heated. H2S, rapidly, expands and mix with the available air. H2S measurements are: parts per million or ppm. Parts or units of gas in 1 million units of air. 10 ppm equals 10 units of gas presence for every 1 million units of air. OSHA standards, established an 8-hour, permissible exposure limit, time-weighted average, that is, permissible exposure limit, and time-weighted average, of 10 ppm, and a 15-minute, short-term exposure limit, permissible exposure limit, and short-term exposure limit, of 15 ppm for exposed workers. NIOSH standards, established a limit of 300 ppm as the immediately dangerous to life and health concentration. Industry practice, most widely recognized, occupational exposure limits, for H2S have referenced an 8-hour, time-weighted average, of 10 ppm, and a 15-minute, short-term exposure limit, of 15 ppm. Primary route of entry: inhalation, through nose and mouth. In low concentrations, the human body can break it down. Over time, or in large concentrations, paralysis of the respiratory system. Exposure levels and possible effects. Between 20 and 100 ppm things began to getting little more serious. You will experience nose, throat and lung irritation, digestive upset and loss of appetite. Your sense of smell starts to become fatigues and you will experience eye pain, tearing, and light sensitivity. Between 100 to 200 ppm you will experience severe nose, throats and lungs irritation and your ability to smell odor will completely disappear. Between 250 and 500 ppm, fluid will build up in lungs. At 500 ppm there will be a severe lung irritation, excitement, headache, dizziness, stingery, sudden collapse, loss of memory, at the period of exposure, unconscious, and death within a few hours. Between 500 to 1000 ppm, there will be a respiratory paralysis, irregular heartbeat, collapse, and death without rescue. Over 1000 ppm, H2S will cause rapid collapse and death may be. Warning system and activation. There is typical 2-level alarm. 10 ppm and 20 to 30 ppm. Emergency preparedness. Safe briefing areas shall be established for all manned H2S facilities. Conspicuous signs shall designate safe briefing areas. For H2S alarms, non-essential personnel shall evacuate the operational areas, crosswind to the upwind safe briefing area. Essential personnel shall prepare to don their respiratory protection and report to their duty station. Steps to follow in case of H2S emergency. First, evacuate, get to a safe area immediately. Move upwind if release is downwind of you. Move crosswind if release is upwind of you. Move to higher ground if possible. Second step alarm, call for help, man down, sound bell or activate. Third step, ASes. Do a head count, consider other hazards. Fourth step, protect. Put on breathing apparatus before attempting rescue. Fifth step, rescue. Remove victim to a safe area. Sixth step, revive. Apply CPR if necessary. Seventh step, medical aid. Arrange transport of victim to medical aid. H2S Training and Drills. H2S training is required for all personnel required to work in oil and gas when H2S concentrations are equal to or above 10 ppm. A drill for each person at the facility is conducted at least once every 7-day period. The drills consist of a dry run performance of personnel activities related to assigned jobs. Drill performance, new H2S considerations at the facility, and other updated H2S information shall be discussed in safety meetings. Documentation must be maintained at the facility where the individual is assigned, or the individual must carry a training completion card. Trained employees or contractors transferred from another facility must attend a supplemental, site-specific briefing on H2S equipment and procedures before beginning duty. H2S Administrative Control. Work practices that can be implemented to reduce potential exposure to H2S include educating workers about the hazards associated with H2S and symptoms of overexposure. Workers must participate in training and monitoring programs in the workplace. Developing safe work procedures for environments that may contain H2S and training workers in these procedures. Proper maintenance and training for engineering controls and other equipment used to control exposure. Using personal or area monitoring equipment where there are potential sources of H2S. This equipment should have audible alarms that will warn workers when concentrations are too high. These instruments should be set to alarm at a level no higher than the occupational exposure limit for H2S. H2S Engineering Control. Engineering controls are used to eliminate exposure to a substance. Engineering controls remove the substance from the air or provide a barrier between the worker and the substance. Examples of engineering controls that can be used to prevent exposure to hydrogen sulfide include the use of ventilation to control hydrogen sulfide concentrations in the air, closed systems that vent to a flare, and treatment methods to remove hydrogen sulfide from liquid and gas streams. Treatment of hydrogen sulfide exposure. Workers who are overcome by hydrogen sulfide must be quickly and carefully rescued to ensure that additional Victims are not created in the process. Workers who do not have the necessary protective equipment must not attempt to rescue others. Rescue workers must be provided with, and wear, a positive pressure, supplied air respirator, and other personal protective equipment, appropriate to the hazards that are present. Resuscitation must be prompt, and close medical supervision of the individual is required for at least 48 hours following exposure. First aid measures. Immediately remove the victim from further exposure. Designated rescuers must wear properly fitting, positive pressure, self-contained breathing apparatus, SCBA, and other required safety equipment appropriate to the work site. If the worker is not breathing, apply cardiopulmonary resuscitation in the nearest safe area. Remove contaminated clothing, but keep the individual warm. Keep conscious individuals at rest. Be aware of possible accompanying injuries. For example, the victim may have fallen when they were overcome, and treat them accordingly. If the victim's eyes are red and painful, flush with large amounts of clean water for at least 15 minutes. Ensure the worker receives medical care as soon as possible. The worker must not be allowed to return to work or other activities. These are suggested questions to be asked about H2S at the work site. Has the potential for a release of H2S into the atmosphere at levels of 10 ppm or greater been evaluated? Does every worker on the work site know where and how an uncontrolled release of H2S could occur? Does every worker who could be exposed to H2S have appropriate training? Is there a procedure to test the atmosphere for H2S concentrations, and are workers trained in this procedure? Is all the necessary equipment readily available to workers who require it? Have you determined if you need a code of practice for operations involving H2S? Are you certain that your workers follow safe work practices developed by your organization? Do workers know what to do in case of an emergency? If the answer to any of the above questions, no, workers may be in danger from exposure to H2S. Respect the unexpected. Think through your risks.